Many winemakers nowadays are choosing to seal their bottles with technological corks. Stoppers made of molded particles of natural cork. They undergo a purification treatment to remove the TCA molecule and other contaminants that can give wine a musty odor and spoil the bottle's contents. Technological corks look very much like the traditional stoppers cut and shaped from a solid piece of cork. They too are made of natural cork, but that's where the similarity ends. Cork is the bark of the cork oak tree. Once the tree reaches the age of about 25, it can be harvested for its bark once every decade or so. To harvest the cork, which doesn't harm the tree, an axe is used to cut into the bark, which is then pried off. A cork oak tree lives for over 300 years and can be harvested up to 15 times. Once the cut planks of cork arrive at the technological cork factory, they're broken into small pieces. They're then ground into granules and are stored in huge bags. The first step is to empty the bags into silos that feed the purification equipment. The machines which purify the cork granules are giant autoclaves. Each one is filled with a metric ton of granules. A compressor is then started which simultaneously heats and pressurizes carbon dioxide. This is until it transforms into a semi-liquid gas called supercritical CO2, which is an environmentally friendly solvent. The supercritical CO2 is injected into the autoclave and the granules are washed in it for 3 hours. The factory's in-house laboratory then analyzes and compares before and after purification samples taken from each batch. This is to ensure that there are no unwanted molecules remaining after treatment. Gas chromatography is then used to separate the molecules by their size and structure. Before mass spectrometry is used to measure the electrical signal that each molecule emits. The type of signal identifies the type of molecule. The signal strength indicates its quantity. Once the batch gets the green light from the lab, it's mixed with a food-safe binding agent and transferred to the molding line. The molding machine is computer-controlled to automatically adjust the molds to the dimension of the stopper being produced. The machine pours the cork mix into molds, which then go to an oven for a few minutes. The ingredients bake into a solid stopper with just the right degree of elasticity. With this process, every stopper made in the same mold is identical, but those made from one piece of cork are never the same, as cork has natural variations. At this stage, this is just the cork's preliminary form. Because next, a computer-guided machining center refines them to exactly the shape ordered. After finalizing the dimensions, it chamfers one or both ends. A chamfer is a beveled edge that makes it easier to insert the cork into the bottle. Each cork then passes in front of a camera that checks for any defects. A few samples from each run undergo a permeability test using this machine. It measures how much oxygen flows past the cork when it's in a bottle. The corks are usually custom marked for specific wineries. Some wineries order a model that appears more like a traditional cork. If so, a couple of extra production steps are required. First, a branding stamp burns lines on the top. Then a computer-guided laser burns a pattern around the side of the stopper to mimic the texture of natural cork. The last step is to brand the required graphics. From ground cork bark to a finished stopper. Then a final visual inspection before being shipped out to the winery. The cork granules are stabilized by a binding agent and molded to a custom shape to block more or less oxygen according to the winemaker's specifications. Some wines require a completely airtight seal, while others require a certain degree of air penetration to mature further after bottling. And I'm sure you'll agree, this item has been a real corker. Zinc gutters are designed to drain rainwater and in the process develop a natural resistance to corrosion. When zinc is exposed to wet and dry cycles, a chemical reaction occurs and it forms a protective patina on the surface. No paint or special treatment needed. These just go with the flow. The process starts with the production of these 42-ton coils of zinc. The zinc arrives at the factory in the form of thick plates, which are almost 100% zinc. The plates are loaded into a furnace, where the temperature reaches 400 degrees Celsius. Some copper and titanium is also added to reinforce the zinc. Once melted, the molten zinc flows to the casting machine. On its way, residues such as ashes float to the top of the metal and are then skimmed off. A floating puck monitors the speed and depth of the zinc blend to prevent overflow. Once at the casting machine, it flows onto a meter-wide piece of steel that slowly unwinds. The steel acts as a mold to form the zinc into a long sheet of metal. Water flows onto the zinc to accelerate cooling and solidification. Since water and liquid zinc don't mix, the water simply runs off the surface. This now solid zinc plate is almost a centimetre thick, but is far too thick for making lightweight rain gutters, so it needs to be dramatically reduced. Which is where this powerful rolling mill comes in. The pressure on its rollers is so great, they have to be replaced often. First, the new rollers are heated up, and then they're activated. As they revolve, the hot rollers exert 7,000 tons of pressure to reduce the thickness of the zinc. The zinc then passes through a steel belt tensioning system. This system prevents slackening in the zinc sheet as it exits the rolling mill and continues along the production line. You can see the difference the rolling mill has made. It's reduced the thickness of the zinc sheet to about 3/4 of a millimetre. The steel belt system maintains the tension in the zinc sheet as it's wound around a core. This produces the 42-ton coil of zinc we saw earlier, and it's known as the mother coil. Approximately 40 kilometres of guttering can be made from one coil. Each mother coil is cut into 3 that are 1/3 of a metre wide. The zinc is now the correct width to be formed, and the factory can now produce the rain gutters. First, a crane lifts one of the narrower coils across the factory so that it can be moved into position to begin making the zinc gutters. The coil is first mounted to a machine that will cut the zinc into uniform 4-metre-long strips. An overhead mirror provides a top view to check that the coil is unwinding correctly. As the zinc passes through the machine, a blade quickly guillotines it into the correct lengths. The zinc strips then travel through a progressively narrower channel over a cylinder, creating the U-shape of the gutter. More rollers refine the shape and also curl the edges of the gutters to reinforce them. This gives the zinc rain gutters their final shape. The automated profiler ejects the 4-metre-long gutters onto a rack that then tips each gutter onto a stack. These zinc rain gutters are ready to hang. On site they'll be soldered together and attached to the roof with special brackets. And now the zinc gutters are finished. I do hope this item hasn't been too much of a drain on you.